In Module 5, Lesson 17 Problem Set, we're going to use our properties, like associative and commutative property, to help us with how we could look at fractions in different ways. So use the following three fractions to write two subtraction and two addition number sentences. So all we're trying to do here is recognize how these numbers could interact with each other. In this case, I have 8/5 and 2/5 and 10/5. And one thing I could do is I could just do simply 8 plus 2 equals 10/5. I could also write it as 2 plus 8/5 equals 10/5. And our subtraction ones, I could do 10/5 minus 2/5 equals 8/5. And 10/5 minus 8/5 equals 2/5. Those would be the four fact families for these fractions, very similar to what we would do with standard whole numbers, just in this situation they have a fractional form with a common denominator. And number two, I think this is kind of interesting. So what you're doing is you're taking a certain amount and you are reducing it. You can either use a number line or solve by counting up and subtracting. So what's interesting is we know that 1 equals a value where the numerator and denominator are the same. So in this case, our denominator is 4. So to represent 1 in fraction form, we have the denominator 4 with a numerator also of 4. So we take the 1 minus 3/4, we take that 4/4 minus 3/4, and we have a leftover 1/4. In this one, our denominator is 5. So I'm going to rewrite this as 5/5 minus 3/5. 5 minus 3 equals 2/5. In the last one, we have 1 and 2/10 minus 7/10. And maybe I don't want it in a mixed number form. So 1 equals 10/10 plus this leftover 2/10. And then when I combine that, it would equal 12/10. And we would subtract that by 7/10 to get 5/10 left over. And we'll continue this over here. What we have is we have some fractions, and it's going to ask for two different ways that we could show a given amount. So in this case, we have 1 and 2/5 minus 4/5. We could separate 1 and 2/5 into 5/5. That would be the 1. And 2/5 left over. We could add these together and then subtract it by 4/5, or we could take this whole amount, subtract it by the partial 4/5, and add that 1/5 to the leftover 2/5. So in this problem, we have this, and this 1 would become 6/6 and 3/6. And what I could do is I could do the 6 plus 3/6 would equal 9/6. And minus 9/6 from the subtracted amount, 4/6, to get a total of 5/6. I could also take that 6/6 of the 1 minus the 4/6, and that would give me 2/6. And I would add that 2/6 to that leftover 3/6 to get another way for 5/6. One last one. In this problem, we can look at 1 and 6/8 as 8/8, that would be the value of the 1, plus 6/8. Sorry about that. So what I could do is 8/8 plus 6/8 would equal 14/8, and then subtract by that 7/8. And that would leave us with 7/8. Another way we could do that is I could take that 1 whole, or 8/8, and subtract it by the 7/8, and whatever's left over, add it to the partial amount. So in this case, it would be 1/8, and I add that 1/8 into the leftover 6/8 to get 7/8. They're kind of interchangeable in that way, and that's the fluidity between whole numbers into fractions and fractions into whole numbers. The numerator and denominator are the same, so I can make it pretty much any denominator I need to go in between mixed and improper fractions.